Okay, so we have an upstream downstream problem. In this, it's mentioned that the man is traveling by a motorboat down a river and then down a river to his office and then back. So effectively downstream in one direction, upstream in another, of course, because the river will flow in the same direction always. With the speed of the river unchanged, so the speed of the river is not changing. He doubles the speed of the motorboat, so the motorboat speed changes, so the downstream upstream speed also adjusts accordingly. Then his total time gets reduced by 75%. So if the total time is reducing by 75%, the time is becoming 25%, right? So there's a reduction by 75%. So effectively the time becomes 25% or one fourth. Okay, now we know that ratio of the original speed of the motorboat to the speed of the river is. Okay, so this is enabling me to or forcing me to take variables. So that is fine. I'll just try to keep it as simple as possible. Couple of things here. Number one, in this entire question, the only thing that I mean throughout, if you consider, I mean even in the upstream and downstream thing, if you consider in that way, the only thing that is unchanged absolutely is the distance, right? And the point is because every relationship is in terms of ratio, and the requirement is also ratio. So the actual distance doesn't matter here. So I'll just consider the distance to be 1. You can consider the distance to be d as well. You'll automatically find that will cancel out. But you can just consider the distance to be 1 in this case. Another thing, because I need the ratio of the speed of the motorboat and the speed of the river. Now check this out. This I do this idea. I mean, use this idea in a lot of different questions. I mean, even something like a quadrant. Then you have a square inside and then a circle inside. You need to compare the ratios of the two things. I mean, the quadrant and the circle. So those cases, I also use this idea. So in this case, we have the ratio of the original speed of the motorboat to the speed of the river. So I just care about the ratio, right? So what I'll do is I'll consider the speed of the river as simply 1. Because now whatever I consider, so this is the only variable I'm going to take, speed of the motorboat. So this is I'm going to consider as a variable. Whatever variable I take, now you check this out. I mean, the ratio automatically becomes m by 1, which is m, right? So if I can figure out the value of m, that itself answers me the question, right? Now, one other thing before we move on. So we have the times, or let me get into that in a while. Just check the scenarios here. There are two scenarios. Number one, in the first scenario, the time taken, the total time that the motorboat takes for the to and fro. So while going downstream or upstream, I mean, first he's going downstream and then upstream. It doesn't matter actually, but then while going downstream, this will be the time taken, right? Because 1 is the distance, m is the speed of the motorboat, and 1 is the speed of the river. So this 1 is the distance, this is the speed of the motorboat, and this is the speed of the river, right? So I hope you are aware of these basic ideas. So 1 by m plus 1 is the time in downstream, and 1 by m minus 1 will be the time in upstream, right? So now if you just quickly resolve this LCM and you check the numerator, you'll get something like this: 2m by m square minus 1. This is the time in the first scenario. And what about the time in the second scenario? These are the two times that we're going to compare, right? The 75% information or the 1/4 thing that is happening. So scenario 2, the time becomes, now the speed of the motorboat is doubled. So now you're traveling with 2m, but the speed of the river is unchanged. So effectively what happens is something like this, right? The speed of the river doesn't change. Sorry, this is a plus. So something like this. Just again resolve this quickly, take an LCM. So 4m by m square minus 1. So we have these two times, right? So this is this is the time for the first scenario, and this is the time for the second scenario. So these are known to us. Now, the times, if you think about the time that we have for the first scenario and the second scenario, the time reduction is by 75%. So the time becomes 25% in the second scenario. So if I consider the first scenario time to be 4, then the second scenario time is 1. So this is the ratio, right? Or simply put, the scenario 1 time is 4 times the scenario 2 times. The scenario 2 time, isn't it? So effectively, this time, this is a scenario 1 time, is 4 times of this time. So just evaluate that quickly, or establish that relationship quickly. So what you have is something like this: 4 times of this 4m by m square, or rather 4m square. Okay, this was 4m square, by the way. This LCM, I there was a typo actually. I meant to write 4m square here. So this is 4m square minus 1. So just this much. Now, if you evaluate this, I mean, you can see this mm cancels off. And again, there's also a cancellation of a 2 here. So what you get is something like this: 4m square minus 1 is equal to 8 times of m square minus 8. So 8 times of m square minus 1. So that is 8m square minus 8. Or what you get is just switching the sides and all. You have 4m square equal to 7, or m square is equal to 7 by 4. M is equal to root over 7 by 2. Don't consider the negative root, that is silly. So m will be the answer if you remember. M by 1 is the speed ratio. So the answer here is root over 7 is to 2. So option B. So I hope this was understood. This is something to do. You can leave these kind of questions in the first scan, because this might take a bit of time for depending on how comfortable or how good you have taken the variables. So if you consider variables for both the motor board as well as the speed of the river, then you might have a little more to calculate with. Again, if you consider the distance, that won't matter that much, because whenever you use the distance, now I hope you understand that. So if you use the distance as a variable, so that will be here, that will be here, that will be here, that will be here. So effectively, when you equate this part into 4 times, that distance will automatically cancel off. So that was irrelevant. That is what I talked about initially. So if you consider the distance, then also again, I just don't make errors in the calculation. That is the only problem that happens if you take too many variables. So if you're cautious there, then you would not make a mistake, but it will take you somewhere from 2 to 2.5 minutes here. So this is a little calculative in nature, but roughly 2 to 2.5 minutes should be able, I mean, you should be able to solve this question. So that's it for this question. I hope you had fun or understood this one variable approach where question itself is forcing you to take the variable. So that's it for this question. Thank you.